Hello again. So far, we've looked at Pythagoras in 2 dimensions. This time, we're going to look at Pythagoras in 3 dimensions. With a cuboid, that generally means the longest diagonal. In this case, it could be, for example, A to G. Now, we don't have enough information at the moment to be able to work this out using Pythagoras. So we need to, first of all, find the diagonal across the bottom of the shape, and then we can use this right angle triangle to find the length. So first of all, we need to find the distance AC. Do this using Pythagoras. So AC squared would equal 12 squared plus 28 squared, and 12 squared plus 28 squared, and I would expect you to be using your calculators at this moment, is 928. So AC is the square root of that, which is 4 root 58. Now to find AG, so AG squared is 4 root 58 all squared, which is this distance, plus 16 squared. Well, we know 4 root 98 squared is 928. So we've got 928 plus 16 squared. So AG is the square root of 1184. And if we square root that, we will get an answer. AG is 4 root 74, which is approximately 34.4 centimetres. And we need to remember to use the unit that was given in the question. So, cuboids are fairly straightforward, but what about other shapes? In this one, we've been asked to find the height of a square-based, well, rectangular-based pyramid. So to do that, I've got the length of this side here. So to find this right angle triangle, I'm going to have to find this distance here, FC. Now, FC is half the distance of AC. And I can find AC because it's just the diagonal of that base rectangle. So AC squared is 9.8 squared plus 14.6 squared. So using your calculator, 9.8 squared plus 14.6 squared is equal to 309.2. Don't forget that's squared, so I need to square root that. So AC is 17.584. So FC, which is this distance here, is half of that, which is 8.792. Now to find X. Now remember, X is the shorter side because the right angle is there. So I'm going to use 12.9 squared. This is for FC. Sorry, this is X squared is equal to 12.9 squared minus 8.792 all squared. So X squared, using our calculator, so I want to do 12.9 squared minus, I've kept the previous answer in my calculator, is 89.11, which means X, I'm going to give it to one decimal place because that's what all those were. So square root my answer is 9.4 meters. And this question was all in meters, therefore my answer's going to be in meters. This is the last type of question that generally occurs. Again, I'm going to be using three-dimensional Pythagoras, but this time I need to find the length of the slope. The problem is basically the same. I still need to find the distance FC. So I need to find AC first and halve it. So AC is equal to the square root of 3.2 squared plus 6.3 squared. I can put that in my calculator. So 3.2 squared plus 6.3 squared. So AC is equal to 7.066, which means FC is half of that. So I'm going to divide it by 2, 3.533. This time, my right angle is still here. I'm finding the longest side, and I know the height is 7 meters, so I'm going to do 3.533 squared plus 7 squared. And to find x, I'm going to square root all of that. So 3.533 squared plus 7 squared, and I'm going to square root my answer. Comes out at x is equal to 7.84. And as it's expected, it's longer than the two sides that I've got given. This answer is also in meters because that's the unit that they gave me in the question. So that's Pythagoras in 3D, and that's basically all they're going to ask. You need to find normally one distance along normally a base and find its diagonal. Sometimes you'll need to halve it, sometimes you don't. In the cuboid, you didn't have to halve it because I'm going to use the whole distance. And then I think about which Pythagoras I need, whether I'm looking for a long side or a short side. Am I going to add or subtract them? Okay, now you're ready to have a go at the exercises. Thank you.